And I'll tell you. All right, well, you can go ahead.
All right. Good evening, everyone, and good evening, Manila, and everybody who is here. Welcome to the .NET Conf Philippines. For this is supposed to be 2020, but it's already 2021, and then we're just happy that we could have this .NET Conf event. I'm John. I'm the UG lead or the user group lead for the Philippine .NET Users Group or FINAG, and I'm also a principal developer at organization called PageUp. So yeah, thank you for everyone being here. I hope you have a good evening. I hope you've enjoyed or you're enjoying your dinner, and we're up for a couple of hours of great great topics that we have. We have two very special speakers lined up. They woken up very early in their morning to be able to be with us. So with that, I hope that you enjoy this event. I hope that you're able to learn a lot. Okay, so tonight our first speaker, he very special guest that we have. So he's the chief technical officer CTO for Magenic, which is a software consulting company that also has offices in the Philippines. He's a Microsoft regional director and is the author of the CSLA.NET open source project. I've always wanted him to be able to talk to Phoenix, so it's an honor to have him here to talk about Blazor. Please welcome Mr. Rocky Lotka.
Hello, everyone. Good evening. It's a pleasure to speak to everybody, and I'm just really happy to have this opportunity. Appreciate the introduction, John. That's fantastic, and I won't rehash too much of that at all. I'll just kind of jump right in here and talk about Blazor and Webassembly, which I think are two of the most exciting technologies, right up there with containers, Docker, and Kubernetes on the server side. I have this vision, actually, that a lot of the .NET development that happens over the next several years an awful lot of it will be running on Linux containers on the server. Whether that those containers might run in Azure or AWS or Kubernetes or some combination of the above, and all of the client-side software. Well, I shouldn't say all, but a lot of our client-side software will probably also be written in .NET and will run in WebAssembly on any Blazor or any modern browser on any device. And so I've just got a few slides so that I can make sure we all understand what's going on, and then I'll do some demos. So in the world before WebAssembly, and I think it's important to understand that WebAssembly now has been built into all modern evergreen browsers for about 2 years. So it's relatively new, but it is widely available. Anyone running Chrome or the current version of Microsoft Edge or Safari or Firefox or variations of WebKit or Chromium, you have access to WebAssembly. And before WebAssembly, though, the way that the browser world worked is that in the browser, really all you have access to is HTML, CSS, and JavaScript. And I know you might say, well, but I've used TypeScript, or I've used Dart, or I've used CoffeeScript, or there are a lot of languages that what's called transpile into JavaScript. TypeScript itself never runs in a browser. TypeScript gets converted into JavaScript, and then the JavaScript runs in the browser. And that's true for everything prior to WebAssembly. And so then you have a server somewhere, and from the server, you deploy the web application, right? You deploy the HTML and CSS, you deploy the JavaScript code, and then any sort of images and data get downloaded. And what has become the kind of default is that that JavaScript encode, you either write your application using something like Angular or something like React. And I know there's a lot of other JavaScript frameworks, but the two big ones for some years now have been Angular and React. And so that's the world that has been. And so I guess you could argue the good side to this is that your only option is JavaScript, right? You don't really have to stop and think about what programming language you want to use to build your web applications, because there is only one. The downside, the drawback, is of course that there is only one, and I have a hard time thinking about JavaScript as the best programming language that humanity can create. Is it really the best thing that we've ever created and ever will in the future? I hope not. So WebAssembly is this idea that, and it's not a new idea. I used to give presentations. I've been a public speaker for a very long time, and back in 1999, 2000, 2001, there was a lot of discussion at that time amongst industry experts and speakers at events about whether the web should be a mainframe-based world where everything runs on the server and the browser is just a colorful terminal, and kind of like a mainframe 3270 terminal or a VT 100 terminal. Should the browser be extremely dumb? Or should the browser become the new client-side runtime? Basically, should we stop caring about Windows or Mac OS or Android or iOS and only care about the browser? And because if we write our applications to run in a browser, then they could run anywhere, and we wouldn't care about the actual operating system. And yes, that was 20 years ago. So that was a big discussion, and it did not get resolved until maybe 10 years ago, when we all started basically writing. Almost every business application now is written in Angular or React, so we clearly have decided that the client runtime is a modern browser. And so if you kind of follow that train of thought, then there are a lot of people that would like to use other programming languages to create their client-side applications, partially because JavaScript is not the best language in the world necessarily, but also because there is a lot of legacy code written in Java and C# and Fortran, and just many different languages that might be difficult or impossible to rewrite into JavaScript. And so the solution to this is to make browsers have an actual assembly language just like Intel CPUs or AMD or ARM CPUs, that where a compiler for, let's say, C or C++ could compile and ultimately generate assembly language that can run natively in the browser. And that's what WebAssembly is. So all modern browsers now look like the picture that you are seeing on the screen, where the what the user sees is created using HTML and CSS. And of course, browsers still do JavaScript like they always have, but now browsers can also run any software that's been compiled into WebAssembly. And so from the server, you can download your HTML, your CSS, your JavaScript, images, data, and also pre-compiled binary code that has been compiled into WebAssembly. So if we look at this diagram, one of the things you might notice right away is that there is no line, there are no arrows between WebAssembly and HTML, CSS. And that's a current limitation of the way WebAssembly works. And so right now, the only language that can interact with the browser's document object model, or DOM, is JavaScript. And so your WebAssembly code, you can write code in JavaScript that calls a function written in C++, for example. But it's also possible for your code written in WebAssembly, like code written in C++, to call JavaScript, and then the JavaScript can update the DOM. And so that's kind of that is the model that everyone is currently using when they're writing UI frameworks using other programming languages that run in WebAssembly. Now, in the future, the WebAssembly roadmap includes the idea of having WebAssembly code directly interact with the DOM. And that will be an important improvement because it will allow a lot of the existing UI frameworks that have been written in programming languages like C# or Go or Rust, for example. Those UI frameworks today have to go through JavaScript to interact with the DOM. And it's going to simplify those UI frameworks a great deal when they won't have to worry about JavaScript at all, and they can be 100% written to run in WebAssembly. So why is this important? And I think it's important on several different levels. One is that I don't think it's ever healthy to have a mainstream programming platform that only supports one programming language. That reduces innovation, and innovation and competition is good for all of us because it forces things to move forward at a good and healthy pace. And so having competition between JavaScript and C and C++ and Rust and Go and C#, all now which can run natively in the browser, is good because it's going to drive innovation. It's also the case that WebAssembly code can run substantially faster than JavaScript. Now, JavaScript over the last many years has become, quite good at being just-in-time compiled, and there's a whole lot of optimizations that have happened. But if you have a complex algorithm that is written in C or C++ or something like that, and compiled with an optimizing compiler, which all modern compilers are optimizing, they're very, very good. And then that code is compiled into WebAssembly. then that code is almost certainly going to be more efficient when running on the client than any JavaScript code. And so if you've got complex graphic manipulation or numeric analysis, or basically anything that's got a really complicated algorithm that needs to run, you're probably going to be able to make it go faster by writing that algorithm in some sort of language like C++ or Rust and compiling it into WebAssembly. And so even if your entire application is still written mostly in JavaScript, writing some parts of it in a more optimized language might give you performance benefits. So all of that is pretty exciting, I think. And the WebAssembly, WebAssembly, and I should be careful here too, because WebAssembly is not a Microsoft thing. WebAssembly, it's started with Firefox and the Mozilla Foundation, and they brought in other companies like Microsoft and Google, IBM, and over time, and obviously Apple to get Safari and WebKit. And so WebAssembly itself is a WC3 standard that's built into all of the browsers. As you might know, for many, many years, in addition to .NET, there has been an open source project called Mono, or Mono, right? It means monkey. But Mono has, for a very long time, been an open source project that has re-implemented .NET on its own. And when Microsoft acquired Xamarin a few years ago, they became the patron for the Mono open source project. But that team is still largely just a public group of folks that do open source work. And somebody, when they noticed that WebAssembly was available, said, "Oh, wouldn't it be cool if it was possible to run .NET, run Mono in the browser natively?" And so they sketched together this prototype where Mono would compile into WebAssembly. And they worked. It was pretty awesome, right? And so then once they had .NET running in the browser, then some folks at Microsoft looked at that and went, "Oh, we could create a UI framework using .NET that would run in the browser." And that's what Blazor ultimately is today. So Blazor is a UI framework built on .NET that relies on the fact that .NET can run in the browser. Now today in .NET 5, Blazor is a supported part of .NET, and actually Blazor was supported as part of .NET in .NET Core 3.1 also. And it basically what it does is if you've ever built a server-side ASP.NET application, you probably have used Razor syntax. That's what ASP.NET MVC uses to create its web pages, and also in modern web server, you probably use Razor Pages, which is a beautiful abstraction on top of ASP MVC. So what Blazor does is it takes this Razor syntax, the idea of a Razor page, but instead of rendering all of that on the server, Razor Pages can render directly in the client as a client-side application, a single-page app. And so ultimately, what renders in the browser is still HTML and CSS, and so you can do all of the cool things that you can always do in a browser with HTML and CSS, but the code that's running in the browser is compiled C# code and sitting on top of .NET. And so this is, if you have ever done WPF or UWP or even Windows Forms, this is kind of familiar because it's the same basic programming model where you've got C# code that is reacting to any events that occur. So the user clicks on something or types something or even mouses over something. All of those are generating UI events that are then handled by your C# code. So it feels, and it's the same if you've done any Angular or React programming, right? It's the same idea. All of this is smart client development. The same event-driven UI concepts that really were pioneered by Visual Basic back in 1991, I guess. And to be fair, it predates that, right? X Windows and a lot of things happened before Visual Basic showed up too. So if we compare this quickly, Blazor versus Angular, in both cases, or React, in both cases, your UI is built with HTML and CSS. In the case of Blazor, your code is written in C# versus TypeScript or JavaScript. In both cases, you're probably calling services that run on your server, either your web server or an application server. The single-page app code is running on the client on your PC or your phone or whatever. The one thing that Blazor brings that's pretty interesting is that Blazor also has this idea of running the code on the server and giving the user the exact same user experience, but the code is actually running on the web server and not on the client. And this is useful for a couple different reasons. One being that it makes it pretty easy to support things like Google search indexing, because when you detect that it's a robot coming in, like Google or Bing indexing, you redirect the robot to your server-side implementation, which is the same, right? You have your app run server-side so they can index your HTML. But when the user uses it, you have it run on the client because it might be faster. The other good reason for using server-side Blazor is that if the user is using an old device that maybe is quite slow, like an older Android phone or something, you can detect that, and it might be faster for all of the code to run on the web server than to run on some old slow phone or tablet. But on the other hand, if somebody's coming and using your application using a modern high-speed tablet or PC or whatever, then it might be a lot more efficient to run the code on the client side. And so you have this option just to easily switch between the two. All of these can deploy as progressive web apps, so they can run offline. And of course, they all host in browsers, and they can all host in Electron. Microsoft has got this experimental thing called Web Window, which is kind of like Electron, but a lot lighter weight. One of the big drawbacks that I think we all know about Electron is like when you run Slack, all your memory goes away, right? Electron is not actually very efficient. And so Web Window is a much lighter weight version of Electron in a sense. Then Ionic has this technology now called Capacitor, which is basically the successor to Cordova. So it allows you to create a deployable app for iPhone and Android that you write it using web technologies. And Angular and React support Capacitor, or I should say Capacitor works with Angular and React. I don't know if Capacitor currently works with Blazor. It might, but I haven't tested that. I don't know for sure. So with that, let's get rid of all of that and look at some code. So to start with, my mouse went away. There we go. So to start with, let's just create a new project. And in Visual Studio 2019, I can create a Blazor app. And so I'll click next here, and we'll let it have its. Well, let's actually let's do Blazor server app. I'm going to start this way, just so that you can see kind of end to end how this works. And now I get the choice here whether I want to use .NET Core. For most of us, it'll be .NET Core 3.1 or 5.0, but I'm going to use .NET 5.0. And I'm going to create a Blazor server app. And so this is going to run on the server, not on the client. And so I'll go ahead and create this solution. And you can do this, by the way, using Visual Studio Code and the .NET command line as well. I'm comfortable using Visual Studio, so I'm using this tool. But if you say, I don't use Visual Studio, I use Visual Studio Code or Sublime or some other text editor, that's fine. You can go to the command line and type .NET new and create a Blazor app that way, and then just use a lighter weight editing environment. It works, everything works the same. You just don't have all of the things that Visual Studio provides. So when I look at the solution that's been created here, what I've got is a modern .NET 5 ASP.NET Core type app. So I've got my startup CS. Well, I've got my program CS, which is what gets launched first. My startup CS, where I can do all of my dependency injection, container initialization. I've got my app settings JSON, and I've got a www root folder here. And of course, I also have my launch settings.json to control how this launches inside of Visual Studio. The www root folder is where I'm going to have my CSS, and by default, they'll bring in Bootstrap and OpenIonic. You don't have to use those. You can use anything that you want, because this is a web app after all. But basically, any static content for your site is going, or for your app is going to go into this folder. And then there's a pages folder, which is where my Blazor pages, which are really called Razor components, are going to go. And they have a .razor extension to them. And we'll get into that in a little bit. You definitely, because this is launched, it's a website, right? So it's launched originally from the server. You have a couple CSHTML files that are kind of for bootstrapping purposes to get Blazor launched before everything runs. And so my actual pages are my index page, a fetch data page, and a counter page. This is of course the default, right? There's also a shared folder, as you might guess. This is where you've got things like main layout or navigation menu, basically any sort of Razor component that you want to reuse across your pages is probably going to go into your shared folder versus individual pages. And then part of the sample start app includes a couple different C# files that are essentially acting as data services. There's also a file here called imports.razor. which contains any sort of global using statements. Because remember, we're in C# basically, right? And so these are namespaces that I want to be available globally. And then app.razor, and this is the actual entry point for my app. So if we kind of step back, when we run this, when I hit F5 in a moment here, what's going to happen is program.cs has my main. So that's what's going to run first because that's running on the server. My main software running on the server is going to use startup.cs to configure everything. Startup.cs is going to navigate the user to the host file. And the host file, which is really kind of my start point for the website, if you will, the host file is going to load Blazor and run app.razor. And from that point, everything running is going to be running in Blazor. And so this is the bootstrapping, right? It runs program CS, configures, runs this very lightweight web page that all it does is download some JavaScript shims and then launches the Blazor app itself. And so if I hit hit F5 here, run this in IIS Express, and you probably noticed when I was starting the app that I could have chosen to run this in Docker, of course, too, on the server side. All of this works great in Linux containers, just as well as it does in Windows. And so here I have my website running. And remember, this one is everything's running on the client side or on the server side. But I can navigate between my pages. And so if I click on the counter page and click this button, now what's happening here is that every time I click the button, obviously this counter is incrementing. So how does that actually happen? Well, what's happening here is that when I click the button, there's a thin layer of JavaScript that's running on the client, and that JavaScript sets up a signal R pipe, communication pipe between the browser and the web server. And so when I click this button, a message is immediately sent from the browser to the server using signal R. And on the server, my code gets a click event. And in that click event, of course, I'm obviously incrementing this counter. And what Blazor does is it sees that I've changed that value on the server. And so it takes that value and sends it back to the client through a signal R message. And then the UI gets updated based on that message. And so I'm not actually doing anything with signal R, right? This is all, to me, this is all magic. When I click the fetch data page, what happens is that because I've navigated to this page, the page runs on the server, calls some sort of a service that retrieves weather data, and then sends that information back to the browser. But I think the important thing that I'm trying to get at here, especially on the counter page, is just the immediacy of this, right? This is highly interactive to the user. It feels like they're in a single page app when in fact everything's running on the server. Now I'll contrast that to, and I'll show you the code here for both of these in just a moment, but let's create a new project. And I'll create a Blazor app, and we'll call this one Blazor Client App 3. And I'm going to create a Blazor WebAssembly app. And so now this app is going to compile into WebAssembly, and it's going to run in the browser, not on the server at all. And so I'll create this project. if we look at Solution Explorer quickly for this project, you can see that it looks largely the same. It's got a program CS because even though this runs 100% in the client, it does have to start something on the server as a static web server so that it can download the files, right? So that's basically program CS does that. In my www root static content now, because nothing's running on the server, right? We actually have an index HTML, and the index HTML is going to download the Blazor, compile the Blazor app, and then it's going to run app.razor. And once it runs app.razor, everything's running in Blazor. And then app.razor ultimately will be loading my pages, which are the same pages I had before. It'll be loading my Razor components that are shared, which are exactly the same ones that I have before. And so if I run this, what's going to happen is it's a little bit different, because now what it's doing is it's compiling the code into Webassembly, and it'll download the Webassembly into the browser. And so it's the startup, the bootstrapping is not the same. But now you can see that this application looks the same and works the same. And now when I click this button, what happens is a little bit different, because now when I click the button, that button click event is being handled by my click handler running in the browser. So I'm not going to the server at all. When I click the fetch data page, what's happening is this page gets loaded in the browser, and there is still a service call that's calling off to my server to retrieve the weather data. But the actual rendering of the UI and everything else is 100% running in the browser. So in that regard, this app is exactly, you can think about it, it's exactly like an Angular or React app, in that everything you see here is running completely in the client side, except for the service call to get the weather data. But what I want to make, what I think is really cool or important to understand here is that the server side and client side app had exactly the same behavior, right? So, and in fact, they have exactly the same code. And so if we look, oops, I guess I should stop. Let's stop that one completely. Is this all running? All right. So if we look at, there we go. If we look at my app.razor page, this is the same in both cases. This is the entry point for the Blazor app. And it says that basically I'm going to set up my router, my Blazor router, and I want you to use this main layout to lay things out. There's a whole bunch of things you can do in app.razor, including setting up authentication and authorization and things like that. But you can see here that this is essentially the 404, although obviously it's a single page app, so it's not really a 404. But if somebody tries to navigate to a page that doesn't exist, this is where they end up. But if we look at my index.razor, so this is the landing page that I end up on. This is like, the simplest kind of page. It says, hey, there's my routing directive. I say my page is accessible using the slash. It's the root page. And now here I'm using Razor syntax, although really it's just HTML to start with, and say, here's some content I want to render. And then it has this tag called survey prompt. Now this is kind of cool, because survey prompt, let me just pin this open here. If I look in my shared directory, survey prompt is in fact a Razor component. And so what I've done, or what Microsoft provides for us, is a shared UI component that I can put on any page anywhere I want if I want a survey. And so you can see that this is not, it doesn't have a page directive at the top because it's not a page, it's just a chunk of UI. It's a reusable UI widget. And I just have a div tag with some, whatever else, and I say, hey, here, please take our survey and let us know what you think. Also, I've got a little bit of code because this is, again, I can write code that provides support for any page behaviors. And in this particular case, I want to be able to pass in a title for my survey. If we look at a little more interesting page, let's look at the counter page. So the counter page, again, has a routing tag at the top that says, hey, I want to get here, you do /counter, some HTML. Here is some Razor syntax that's saying, I want to display the current count, and I'm using @current count here, which is basically a type of data binding. If you really think about this, if you're coming from a XAML or Windows Forms background, this is a type of data binding, basically. Also, I've got a button, but notice that my button has an on-click handler that goes to a method called increment count. And so in my code, my C# code, first of all, you'll notice that I have a field called current count. That's what I'm data binding to here. And I have a method called increment count. And that's what I'm binding to the click event for the button. And now this one, this method is obviously very simple. It just increments the value. But see how simple this is, right? Very simple, very straightforward. And this code is identical whether it's running on the client or the server because that's the way Blazor works. All right, let's, in the little bit of time I have left, let's look at a slightly more sophisticated example that I think hopefully shows just a little bit more of what you can do and will maybe inspire some of your. So as you might have noticed, when I ran this particular application, it's the server-side code for this one is running in Blazor. So this is all running on a Linux container in Blazor. I still have the counter and the fetch data pages because it just makes for a good demo. But the interesting part here is that if I click list people, now what's going on is I'm actually using the open source CSLA.NET business logic framework, and it's making a call to the server, to an application server, retrieving this list of people. And I can say, oh, I'd like to add a person. Oh, I can't because I'm not authorized. Well, maybe I better log in. And this doesn't really log in. This is, again, it's a demo app, but it logs me in using a claims-based model, which is important because Blazor, ASP.NET Core, and Blazor now only support claims identity and claims principle. But you can see I've logged in with a username of test user, and I'm in role admin. And so now if I click list people and say I'd like to add a person, now I get on a page. But now this is a whole lot more interesting, right? Because notice that it says the name field is required, person name required. If I start typing a name like Rocky, notice that it says, oh, check capitalization, because now I've actually got, I went from name is required to saying check capitalization. Well, that's because we assume there's a rule that says, well, you maybe should have your first letter be capitalized. But notice that it's a yellow, it's a warning, not an error. you can still save this person. It's just like, are you sure? Right? But the kind of the key thing here is notice that these rules are changing in literally as I press each key. The rules are being run, and that's because the CSLA rules engine is running right here in the client on the browser. And it's able to run on each keystroke because I'm not going to the server, right? I can create for the user the same rich, interactive kind of user experience that I think we all wish we could have. Now this particular application has a very strange rule for the purposes of demo in that the letter Z is not allowed in any name. But notice again that as soon as I type a Z, my rules come into play. You might, nobody would do that in real life, but you get my drift, I hope. So now if I save this person, it's saved. I can go and I can edit a different person. And notice that this name length field here is changing as I type, because again, that's just another business rule that's running, is that we want to have the name show up. So this solution is a little more complex, and I think I can't go through it in detail in the interest of time, but I want to show you just to inspire some thought, right? So this solution is has a Blazor client project, and it also has a Blazor server project, because this app is running. It's a single page app, so all of the pages and everything are running on the client. But in this case, the server actually does do some real work and has a data portal controller for CSLA. It still has the weather controller. And so the kind of the key thing I think here that I would like you to understand is that the server is in fact doing two things. One, it's a static file server to deploy the Blazor app to the client. And also it's an app server that has controllers that are being called from the Blazor client app. There's also a Blazor shared project here. So all of these classes, all of this code is compiled into a .NET standard DLL. And that DLL is deployed to the client and to the server. And so all of the code that's in here, such as my person list or my person info or the weather forecast class, all of this code is literally shared. It's deployed to the client and to the server. And so you can use the person edit class, all of these properties, all of these business rules, and everything that's in here runs on the client and the server as needed. And for anybody who's followed my work with CSLA over the last like 23 years, you know that the whole concept behind CSLA has always been to have code shared and deployed between the client and the server. And so Blazor, the fact that Blazor is built with this idea of sharing code between client and server makes me very excited, because obviously this is something I've been advocating for a really, really long time. If we go down a little further, this particular project actually uses a injectable data access layer, and so it's got some data access types, but then there's an entity framework implementation, and also a mock data, an in-memory database for testing purposes. And so if we look up in particular in my startup.cs, where we do all of our configuration, we'll discover, for example, that I'm adding the mock person database implementation, but I could, of course, instead use the entity framework implementation, and then obviously I would have to configure entity framework itself so that it has access to the database. But you can hopefully see how Blazor sits on top of ASP.NET, uses all of the cool dependency injection configuration, and lets you do things like configure how you're going to talk to your database, where your database is, and all sorts of stuff like that. I'd also like to point out, and if we come back to app.razor on the client, that this app, like I pointed out, uses authorization. And so what happens here is that in my top level routing page, I say, well, actually, I don't want to just route you. I want to route you based on authorization. And if we're authorizing, then we want to tell the user we're authorizing. But what really happens here is because I've told Blazor to incur a little bit of extra overhead and authorize as we go into every page, that means that in my pages, like in my edit person page at the very top here, I can have an attribute that says that only users in the admin role can get to this page. And so that too, this is a feature of Blazor that I think is really compelling because it's sitting on top of ASP.NET Core, and the way that ASP.NET Core uses claims-based authentication and authorization, and it's just extended into Blazor. Now in practice, this authorize attribute can get really sophisticated because it has the simple model where it just looks at roles, but it can actually invoke methods to do much more complicated decisions based on the user's identity and claims as to whether they can or can't get into a given page. Also in this page, because this is the data entry page that has validation, you can see that at the top I'm able to display maybe some error message that if there's any sort of error talking to the application server. As the page loads, my data won't yet exist. I don't yet have a model, and so I'm going to display that I'm loading person data. But once the model is not null, once I've actually got the data back from the server, then I'm going to say, okay, well, here's the table. I probably should have done this with div tags, but I'm not the expert web developer here. Besides, this goes to show that this is just HTML, right? It's Razor syntax. So I could use fancy div tags, or I can use tables, or whatever I want. And then in my rows, so here's the ID number. And now some of this relies a little bit on the features of the CSLA rules engine, but here I'm saying, is the user authorized to see the name property? And if they are not authorized to see it, I'm not going to show it to them. But if they are authorized, then they get to see it. I'm going to show them the friendly name, but then I've got this text input. Well, what is text input? That's a weird tag. And so if I look at my shared folder here, I've actually got another UI widget that understands text input. And so here I'm using an input tag in order to get the value. But notice that I've actually also I'm saying this input field should only be enabled if the current user is authorized to write to this property. In other words, if the current user doesn't have authorization to write to the property, they'll get to see it, but they won't be able to edit it. Also, I'm displaying any error text, warning text, or information text, which is how those red, yellow, and blue text showed up underneath that text box. And so the really important thing, I think, here, and this is maybe the most kind of compelling feature of Blazor, in my opinion, is that I can create these reusable things like text input, use it throughout my application. And if I decide that I need to change the style, look, or behavior of how text input works across my entire application, I can just go to this one place, change this one UI widget, and now I will have globally changed everything to do with inputting text across my whole application. Now, if you go look in, if you go to cslanet.com and go look at the GitHub repo for csla.net, in the samples folder, there's a sample called Project Tracker. And that one actually takes us a step further and says, this entire block of code here, that could be a thing all by itself. And so in that project, it actually is text input row. Let me just copy paste this. And we are able to get rid of all of that. And so then you can start to say, well, actually, every one of these can become one line. This can become one line. This can become one line. And so you really shrink the amount of UI code that you're writing and make your overall application almost infinitely more maintainable. So this was fast. I know I went through an awful lot of stuff very, very rapidly. I guess I don't have a closing slide here, so we'll just leave it on this page. But I appreciate you taking the time this evening. I hope this is exciting. I think Blazor, if you're coming at it from a Windows Forms, WPF, UWP background, Blazor is kind of, in my mind, kind of a natural. It's got all the goodness of HTML, CSS, plus all the goodness and actually better of things like XAML data binding and eventing. It's a beautiful UI framework. If you're coming at this from an Angular or React perspective, it's going to feel pretty familiar, other than you're going to be writing your code in C#. But realistically, all these things are just ways of creating smart client apps that run in any modern browser, right? Very, very, very exciting stuff. So with that, I'm going to call it a day and thank you for your time.
Thank you so much, Rocky, for that really good talk on Blazor. Yeah, so maybe I will start off with my own question on this, because I haven't been able to explore Blazor as much before, and one of the things that I did not understand was clearly was that difference between the server and the client, and how to use them and what scenarios to use them in. And one thing that was on my mind was that weather forecast demo that the Blazor has always had. If you create a client application, for example, and it's a purely client app, does that mean that the call to the weather forecast service is coming from the client? Is coming from your machine, or is it coming from a server and getting called?
Normally, what you would, if your code is all running on the client, you're going to make an HTTP call to an application service to get the weather data. Mm-hmm. So the data itself is not on the client; it's coming from some server, a service somewhere.
Yeah, so, it is.
Yeah.
Mm-hmm. Yeah, but I mean, if you made your Blazor app purely a client-side one, the client-side implementation, when it calls that weather forecast, where does the call come from?
Well, if you're writing an app that is 100% client-side and does not call any services, obviously then it wouldn't be able to get something like weather data unless that weather data was already on your device.
Yeah.
Right?
All right.
right? I mean, that's just true of any client-side app. If you don't have access to any servers, then your application can only do things with data. But that's where I think being able to deploy as a progressive web app is maybe important, because you can think about an application that an insurance adjuster or somebody on a construction site might use, where maybe they don't have internet connectivity. So before they leave the office in the morning, they download all of the data they need for the day. They go out into to do their job, and their application is running on the client, working with data that's on the client. And then when they get back to the office at the end of their day, then it would synchronize with the servers when they have access to the internet.
Cool. That's really good insight. Anyway, just let me take this time to welcome Brian Lagunas, who's gonna be our next speaker.
Hey, Brian.
Hi, hey, Brian. Well, we're going to get back to you. I think there's only just one question from the audience. Joseph Manangan, and he was asking about do we have any public repository for this example solution? Maybe he wants to try it out for himself, and maybe studying it. I was both surprised and glad that you were able to show us a sample that used CSLA.NET. CSLA has been around for a long time, and being able to bring all the principles of CSLA into something as new as Blazor is really a good sign. I know for this technology, that this is something that we could incorporate to some of our legacy apps if we want to make new parts of web application, or new versions of web applications. Something that we could use our existing backend code for, perhaps.
Yeah. So CSLA is, of course, an open source project and has been for like 23 years now, and so it's on GitHub. And I put a link into our private chat here, so I think it'll show up maybe on the YouTube channel or whatever. But the easiest way is to go to cslanet.com. And that'll have the link to the repo and the downloads and the NuGet packages, and all the information is there.
All right.
I personally have used CSLA.NET in a number of large enterprise applications, and I would not develop a large enterprise app, desktop app, without it personally. It's awesome.
Well, it's a beautiful endorsement. Thank you.
All right. So, right, for lack of a virtual clap machine here or something, thank you very much. Thank you very much, Rocky. and thank you so much for being here. We know it's now 6 a.m. where you are, and we're really grateful that you gave us this chance. Any last words before we say goodbye and move to the next talk?
Well, it's been my pleasure. I really appreciate the opportunity to speak, and it's early in the morning for me, but it's in the evening for you guys, and so it's it's all great, and I'm really glad that I've had this opportunity, and I wish you all the best.
Thank you. We appreciate your time. Thank you so much for that. All right, so that was Rocky Lotka in his talk about Blazor and how it plays with CSLA.NET, which has been around for almost a quarter. Wow, it's so hard to say that, almost a quarter century.
Yep, 23 years.
Yeah. So we move on to you, Brian, and thank you so much for getting up at 5 a.m. Now it's 5 a.m. your time.
Now it's
right?
5 a.m. I've been up since 4. I was just so excited. I woke up early. I'm like, I can't wait.
All right. Thank you so much for being here and for accommodating us. So before we move to your talk, so just to introduce everyone to Brian here. So Brian is I'm not sure if this is still updated. You're a senior product owner at Infragistics?
Yep, Infragistics.
Yeah, and he's the co-leader of I don't know if I'm saying it right. Boise.
Boise
Boise
Code Camp. Yeah,
Right.
well, yeah,
Boise Code Cap and Net
NetDoug.
NetDoug, and yeah, and you're here to talk to us about Prism and using that for Samuel. So I'll let you take the floor and go for it.
Yeah, no problem. Yeah, just give me the floor. Let me set my timer. How long do I have to talk? I'm just because if you don't stop me, I'll just keep going. So I got to set a timer. So how long do I have?
I'll give you 50 minutes.
50 minutes? Oh my God, that is not much
Well,
time.
you can go
50
for
minutes.
All right. Well,
Okay,
have fun.
All right. So the way this is going to work is I need questions. So be sure to add comments in the comment section. I will be monitoring them. Feel free to ask a question as I talk. I'll constantly be glancing over. But a little bit about me. My name is Brian Lagunas. I am a senior product owner at Infragistics, where we write basically the world's best UI components to use in your applications, be it Angular, Blazor, WPF, WinForms, ASP.NET, React. Doesn't matter. You need charts and grids and maps and all that cool stuff. We have them for you. I'm also most well known for being the owner and maintainer of Prism. So while I do I am actively involved in my local community with Boise Code Camp and NetDoug, I'm also more active in the global community, as you can see here. I'm speaking at your event here in the Philippines. And so I'm also a Pluralsight author, trainer, all that good stuff. I like to do community stuff. If at any point you would like to reach out to me, the best way to do it would be on Twitter. Just hit me up at Brian Lagunas. You can see the link right over here. Please subscribe to my YouTube channel, youtube.com/Brian Lagunas. And I live stream every Thursday, which is, for me, it's today, on Twitch. So I live stream on Twitch at twitch.tv/Brian Lagunas. So you can reach me there at any time. And so today, I'm here to talk to you about building composite XAML applications with Prism. And you're probably thinking, what the heck is a composite XAML application? Well, I'm glad you asked, because it's something, this is how you need to be writing applications. Let's talk about some challenges as a developer that we run into when we write applications, right? First, your team, right? Even if it's just two people, like here I say large teams. I come from the enterprise. I'm used to writing really big applications. So I'm used to dealing with large teams that span multiple continents, right? And so one of the big challenges you have when dealing with teams or just more than one person is that you're always working on the same project files, right? Or the same projects. And you're trying to work on functionality that may be different, but touches various portions of the application that may be in the same files, right? And so that is a challenge that we have to overcome. And this comes into play really when you're dealing with source control. You're trying to check in and do those merge conflicts. It's like, dude, I was working on the same file you were, and it's a big mess, right? Another thing we have to worry about is duplicate infrastructure code throughout. What this means is, and I'm not necessarily talking about code reuse within your application, like you have the same method defined. I'm talking about full-on infrastructure being reused. For example, the simplest example I can think of is maybe like a login process, right? You have a standard login screen in your company. You have login code that handles authentication, authorization, and you wind up kind of duplicating that in every application. Wouldn't it be nice just to have like a little module just dedicated to login and just add it to whatever application you want and it just magically works, right? Another thing you have to worry about is like consistent project structure. This is something I get on a lot of devs because I feel this is really important. When you're dealing with a lot of applications, especially in an enterprise, it's important to have the same project structure, to write your applications the same way. There's a number of benefits to this. First of all, you'll be more efficient writing applications. When you have a pattern, when you have a standard, if you will, you'll be more efficient and less likely to make mistakes. And also, what I really like about this is context switching. How many times when you're jumping from one app to another app to another app, oh, I got to fix a bug in this app. Oh, I got to add a feature to this app. Now I got to go to this app over here. Well, if your projects are structured in the same way, or at least very similarly, the context switching isn't as dramatic, right? It's easier to go from one application to another without having to like completely change your thought process on how the application works and things like that, right? So, and another benefit to this is bringing on new devs. That's another benefit. And another thing we have is code quality. We all know what code quality is. When you have standards in place, your code quality normally goes up. If you don't, and you just kind of write an application one-off, you're going to be writing things differently every time. So that can really hurt your code quality quite a bit, actually. And then obviously the biggest challenge we have is that app requirements change over time. So you're constantly updating code, maintaining code, extending code, adding new features. And so we want to protect ourselves from having a volatile code base to where maybe we're breaking crap all the time, right? We don't want to do that. We don't want to break stuff. And so if we look at a typical application design in the enterprise or really anywhere, this is what we refer to as a monolith, right? A monolith, one big application. And I'm not necessarily talking about, I have a class library or I have some UI controls. No. So imagine we're in Visual Studio, right? And we have a main project. And the main project is essentially the application. And like I said, I'm not talking about the class library or the user control library or the business CSLA class library, right? I'm not talking about that stuff. I'm talking about all the views, all the view models as you're using MVVM, which you should be in a XAML application, but all the views, all the view models, all the services, basically all the code, all the logic, everything that makes up, your application, it kind of resides in one big executable. And that's not how we want to do things, because this design completely goes against all those challenges we have. All those challenges we just talked about are amplified in a design structure like this, right? Imagine, trying to modify, extend, or maintain any of this code with multiple teams. It's not pretty. It's not pretty. So what we want to get to is something more like this, right? So now imagine you're inside Visual Studio, you have your solution, but now we have our main project contains what's called a shell. And a shell is just like a master page, right? And it doesn't know anything about your application, really. It's very dumbed down. And it'll have mainly one view. It's going to be your shell, which is like the main window of your application. And then what we do is then we have different projects. And we'll have a project for each major functional area of your application. We refer to that as a module, okay? So a module represents a major functional area of your application. So if you imagine like Outlook, right? Outlook has like mail, contacts, calendar, right? You can kind of think, oh yeah, you know what? Each of those sections, each of those major functional areas of my app could be pulled out into a separate project. And then what happens is at runtime, these modules are loaded into the application and we can start injecting these views into the main shell without the shell even knowing they exist. That is beautiful. And so that's what we're going to learn how to do today. We'll try to in 43 minutes. Okay. So how do we build modular applications? Well, we're going to use the Prism library because it's been around forever. Like literally, it's been around since like 2008, I think. Like, been around a long time. And so what is the Prism library? Essentially, the Prism library is a XAML application framework. It's about guidance. It's about patterns and practices. It helps you write testable, maintainable, extensible code that can evolve over time and be really a stable code base, okay? And it's really all about guidance, guiding you down a path, right, to write successful applications. Now, I'm not guaranteeing you that you're not going to be able to write crap code using this framework. Oh, you most definitely will. But it's harder to do because of the framework that Prism provides you. It really helps guide you down that path to write good, clean, extensible code that's separated. We have separation of concerns. It's testable, all that great stuff. Okay. And the best part about this, it doesn't cost you anything. It's open source. It's part of the .NET Foundation. It's on GitHub. We'll throw a link out there later. But the code's all out there. It's nothing to it, right? It's open source. Everyone loves open source. It means it's free. And this will help you be successful. I've never personally written an app with Prism that has failed. How about that? I'll throw that out there. Now, you may be asking yourself, okay, so what's included in Prism here? What do we get? What's in the box, Brian? What is this? Well, first, obviously, MVVM support. You're going to get that. Now, it's very important to understand that, Prism doesn't require MVVM. You can use code behind with Prism if you want, but I will always be talking about MVVM and showing you MVVM because it's all about separation of concerns and testability. We get commanding. This is your delegate commands and composite commands. You might not have heard of a composite command, but composite commands are pretty cool. Messaging. So this is like we have what's called the Event Aggregator, which allows you to have like a publish, subscribe messaging system. So all these modules that we're talking about, what I was talking about earlier, I can actually send messages to these modules, and they don't even have to reference each other. So if I have two modules, module A and module B, I can send a message from A to B with no reference at all. They have no reference to each other, and I can communicate between them. Probably the most important and the most used feature in Prism is the navigation framework. There's a number of ways to navigate, but region navigation is king. We also have a number of services for showing dialogues. Modularity, talked about that, separating these major functional areas of your app out into separate projects. And then lastly, this is the one that confuses people the most, is dependency injection. Dependency injection is a concept for creating loosely coupled applications, for managing dependencies. So you're never newing up services; they're all just kind of given to you. And I'll briefly touch on that during our demo very quickly. And so that's all the slides I had. I think it's important that with the time I have remaining, we should just jump in and start writing an application, and we'll just write as much as we can. Okay, so it's important that you ask questions. Because your questions will help drive where this demo goes. Okay, this is not a scripted demo. I don't know what I'm going to write. I'm making it up as I go along. So the easiest way to get started writing a Prism WPF application, in this case, I'm going to use WPF, but Prism supports Xamarin Forms and Uno as well. So if you want to write Uno applications or Xamarin Forms applications, you can use Prism for that. In this demo, I'm going to use WPF. Just because it's faster. Okay, so the first thing you're going to want to do is you're going to want to open up Visual Studio, go to Manage Extensions, and you're going to want to search for what's called the Prism Template Pack. It's right here. Let me just scroll that up right there. You're going to want to install this because this has a number of item templates and project templates and code snippets that make writing Prism apps just easier. Okay, so the first thing I'm going to do is I'm going to create a new project. And this project is going to be a Prism blank app. We'll do .NET Core. And I will call this my Prism demo. Now, the first thing that's going to pop up is you're going to get a wizard, kind of asking for your container. Now, this kind of goes back to the DI stuff, right? I'll touch base on this, but for now, I recommend Dry IOC. It's lightweight and fast. There's also Unity, and you can do your own custom container if you like. But out of the box, Dry, IOC, and Unity are supported. I'm getting a question here. Pablo! Hey, Brian, may I ask, what is your coffee? I don't drink coffee at all. I just drink water. That's all I drink. Can you imagine me on coffee? That's ridiculous. Okay. So we have created a Prism application. So what is a Prism application really? Well, let's just take a look at our app.xaml. And really the only difference that you'll see is that instead of the app.xaml implementing application, this is now a Prism application. And I may need to make is my text okay? Should I make it just a little bigger? Maybe like 115 maybe? That work?
A little bigger, yeah.
Yeah, a little bigger. How about 120? I hope that's global. I don't have to keep setting that for everyone. Okay. So now if we look at our app.xaml.cs, now we can see it's a little more different. We have two methods. One's called create shell, and then we have another override called register types. Okay. Now, I briefly mentioned this in the slides, but Prism has this concept of a shell. And a shell is essentially, like I said, it's a master page. It's the main window of the application that we're going to start injecting stuff into. Okay, we don't know where it's coming from. The shell has no reference to anything. but we're going to start throwing views into this shell. And so if we look at our shell, it's just a main window, and it has what's called a region in it. Now, a region, you can see here, Prism Region Manager, region name equals content region. All I have done here, as I said, hey, Prism, you see this content control here? Yeah, I want this to be a region. And that means that I want to be able to add content to this content control dynamically at any time. You have no idea where it's coming from. You don't know when it's going to happen. Just be ready for it. And so when you define that region, that component, that control, in this case, a content control, just sitting there waiting for content. Okay. So I'm going to leave this here. Okay. And we'll also get a view model for our main window. And it's a very simple view model. It has one property in here called title. We're setting it to Prism Application, and it's deriving from bindable base. This is just a base class in Prism that implements iNotify property change. That's it. That's all it does. So if you look at this property here, you can see in the setter where it says set property, this is from bindable base. This is just a helper method. You don't have to use this in your applications. It's not required at all. So Omar says, a lot of developers says the size is very big of Prism. No, the size of Prism is tiny, tiny, tiny. Like here, let me just show you here. Let's do a build right quick. I'm just going to prove it because I hear that a lot, and that's people just repeating what they hear. Okay, it's not based on experience. Let's open this up. Go to our bin, debug, netcore. So Prism itself, 75 KB. Prism for WPF, 145 KB. And then you have the dry Odyssey, which is 28 KB. That is not big at all, especially on a WPF desktop app, okay? So Prism is very, very lightweight. Okay, thanks for the question, Omar. I appreciate that. Okay, so this is the view model. Now, the next question you're going to have is, whoa. How does the view model get applied? So I'm going to run this application. We're just going to see what happens when I run it. And it's just a window. It's blank. We haven't done anything, but here's our title being bound in our main window, Prism Application, right? It all works, Prism Application. But if we look at our view model, or excuse me, if we look at our code behind, we can see that we're not setting the binding, the data context to the window, right? We're not doing this. We're not saying data context equals new main window view model, right? We're not doing that. So how is that view model being set? Well, it's being set by this attached property. It's called the view model locator. So we set the view model locator.autowire view model equals true. What that does is it by default uses a convention that says, hey, Prism, you know the name of my view. It's called main window. Well, go find a view model in the view model's namespace called main window view model, create an instance of that for me, assign my data context, and just let me be on my way. Just do everything for me so I don't have to worry about it. And that's exactly what it does. So the great part about this is it uses a dependency injection container, which I'll talk about when we start injecting stuff, to automatically create this for us and set that data context for us automatically. So very easy to do. Now, first things first, we talked about, the composite modular experience, breaking these big applications up into separate projects, into modules, and we're going to have all this cool stuff just happen magically. Well, let's do that. The first thing I'm going to do is I'm going to create a module. So imagine this as like a major functional area of your application, whatever it is. Like if you're talking about Outlook, maybe it's the calendar module. Maybe it's your admin module or like your mail module, like whatever, right? Like a major functional area. So I'm going to create a new project. In this case, I need a module. Do I have it? Yeah. So I'm going to create a Prism module. This is part of the Prism template pack for .NET Core. I'm going to call this module A. I don't care what I call it. I'll call it module A. And so what it's going to do is it's going to create a class library for me that has a few files in it. The first one being a class called module A module. And all a module really is to Prism, it's a class that implements the I module interface. That's all it is, okay? So the template pack just makes it easy for you. And you'll see this interface has two contracts on it. It says uninitialized and register types. We'll kind of get to this, hopefully we'll have time to really get into DI. All right. So the next step, oh, excuse me, and we have a view. What's this view? Does this view say anything? We may have to add something. Yep, it has a message. And then do we have a view model? View A from your Prism module. Okay, perfect. So we have a message set. Perfect. So what I want to do is now we have to let the Prism application know about this module. And there are a couple of ways to do this, right? One way is just through code. And that's what I'm going to do. I'm going to add a reference from the main executable to the project. Okay, so this is a tight coupling on the module side. Now, you don't have to do it this way. You can actually load your modules from a directory, from a network share. You can use an app.config file to load your modules. You can use a XAML file to load your modules. So if you want a more loosely coupled, like this executable really has no idea about your modules, you could totally do that. No big deal. Okay, so we've added a reference to our module. So let's go back to our, I'm going to close that, and I'm going to keep that open. Okay, so let's go back here. Now, what we have to do is we have to let the application know about that module. So I'm going to override configure module catalog. And let me scroll this up so everyone can see. So I'm going to say module catalog, add module, module A, module A module. And that's all I did. Okay. So now let's do something. Let's hit a breakpoint on our register types and on initialize in this class. Okay, so let's go ahead and run the application. We have let Prism know about our module, and so let's run the application. Boom. Okay, I hit a breakpoint on the register types. This is where we're going to register any of our services and types with our container for this module, and then after that, on initialize this call, which we will do any type of initialization code that we need for our module. Maybe we're injecting views into menu items and things like that, right? And then it opened up on this window, and the application runs. So our module is loading, okay? Now, any questions so far? I'm monitoring here. I'm not seeing anything. Oh my God. Ooh, wrong. Ooh.
You
Wrong
okay,
too.
Brian?
Woo! That went in my lungs.
Take it
Note to
easy.
self: don't try to talk and drink water at the same time. Take a breath, then drink. Okay. So now that we have a module, let's inject this view A into this region. Okay. Now, to do this, we're going to go to our module A module class, and now we're going to show a view. And the way we do this, there's lots of ways to do this, but I'm going to show you the coolest way, which is using what's called region navigation. I'm going to navigate that view into that region. To do that, I need what's called the I region manager. So I'm going to start by creating a constructor for this class, and then I'm going to ask for the I region manager. Okay, and I'm going to add a field to store that off on. Now what I'm going to do is I want to navigate to this view, but before I do that, I have to do something that Prism expects. I have to register my views for navigation, right? The navigation framework has to know about these views in order to create them. So what I'm going to do is in register types of the module, I'm going to say container registry, register for navigation, and then the name of the view, view A. Okay. What this does is it registers the key, the name of the view, view A, with the container. If I want to provide a custom view or a custom name, I can do that. My name. Essentially, it's important to understand that navigation in Prism is URI based. It's based on a string. We don't navigate to objects. We navigate to like a key, to an ID, to a unique identifier, because this keeps things loosely coupled, okay? So now in the onInitialized, I'm going to say region manager, request navigate, name of the region, which is we go back to our main window, we can see that our region name is content region. Okay, so that's the name of the region. And then we're going to the source. What are we navigating? We're navigating view A. Okay. Now, if I did say my name here, if I put a custom name in here, guess what? I can't navigate to view A. I have to navigate to my name. Okay. Just keep that in mind. But for the most part, most people just keep it default. Okay. So let's go ahead and run the application and let's see what happens. Bam! Check that out. That's our module. That's our view. Okay, so we have successfully injected that view using MVVM and all that stuff into the region that's defined in the shell without ever really adding anything. All we said is, hey, navigate to this region, this view, you're done. That's it. Okay, we look at our main window. This is all that's here. There's no code to require that. So from anywhere in my application, in any module, I can inject stuff into this region or any other region. You're not limited to regions. You can have more than one region, right? So very loosely coupled way to navigate. Another cool thing about this is that we can, we can pass parameters, which we'll get to in a minute. Now, I want to make a note here. You see how I just injected this region manager? This is what dependency injection is all about. Dependency injection, you can think of it as this like, okay, imagine like a dictionary of types. And this dictionary has a collection of all the types that it knows about. And anytime you want a type, you just ask the dictionary to give it to you. And so that's kind of a very simplified way of describing a dependency injection container. As long as the container knows about a type, all you have to do is ask for it, and it will create it for you. And if that type has any dependencies itself, it will create those too. So for example, nowhere in this application have we newed up any view, right? I didn't new up this view A. We don't have any code in here that goes, like, var v equals new view A. We don't have any of that code, okay? But if I wanted to, and I needed something in my code behind, I can change my constructor. Oh, you know what? I really need the Event Aggregator. Oh, if I can spell. From Prism to send messages from this view. All I have to do is ask for it. I'm going to run the application. I made no other changes. I just asked for this, and look, it gave it to me. I have an instance of it. It created the instance for me, and my app didn't break. I changed a constructor of a view, and my app didn't break. No compile errors, nothing. And that's because we're using dependency injection to resolve our objects. So the Prism application, you see this register types. The reason we have the Prism application class is because it registers a number of types for us, right? The region manager is registered. Like all the services that Prism relies on is registered for you automatically, so you can just use them. But if you have a service that you want to use, like iPerson service, that's where register types comes in. This is where you let the container know about your types. So for example, if I had a service such as I want to register a singleton of type iPerson service, right? And whenever I ask for iPerson service, give me person service. That's all you're really doing there, okay? That's all that is. You're just letting the container know about your types. Okay. Now let's kind of get into, we talked a little bit about navigation here. What do we do now? What do we do now? How about we do some... Okay, I got it. How much time do I have? Oh, man. You did not give me a lot of time, my friend. I need more time. Okay. I want to talk about some of the other features that we have. First off, continuing on navigation, let's go back to our module and let's talk about parameters, right? I want to pass a parameter. Let's say I'm navigating from one view to another view to another view somewhere in the application, and I need to pass parameters to my views. Well, I can do that by creating a new navigation parameters class. Let me scroll up so everyone can see that. And now what I can do is I can add new parameters, say, for example, message. All right, this is just a collection of a key value pair. My message is hello parameter. Okay, but it doesn't have to be just text, right? I could pass in like a ID. I could pass in, I don't know, 1,235, right? It could be an object that you want to pass around. And when I want to pass this parameter to the view, like in this case, I want to pass it to view A, I just pass in the parameters as an argument here, okay? So now let's talk about how we get to those parameters. Let's go to our view A view model. Here's our view model. And what I want to do is I want to implement what's called navigation aware. Add my namespace, implement the interface. Now, there's 3 contracts or 3 methods on this interface. OnNavigated2, which makes some sense, right? OnNavigated_from, and then isNavigationTarget. This is a more advanced topic, but for now, we'll return true. OnNavigated2 is obviously whenever this view is navigated to, this will be invoked. If I'm navigating away from it, OnNavigated_from will be invoked. In this case, what I want to do is I'm expecting a parameter. So I'm going to set the message property equal to the navigation context at the parameters. I'm going to get the value. Whoops, not get enumerator. Get value. This is of type string because we have to cast the type because we don't know what the type is. Message, right? So I'm passing the message as a parameter. I'm getting that parameter, and I'm going to use that as the message instead. Let me drag this over. There it is. Boom. Hello parameter, right? And so you can pass as many parameters as you want. Go at it. Knock yourself out. Okay. But that's how easy it is to pass parameters back and forth. Another thing I want to talk about is the more common things that you'll have to deal with in your application, like commands, right? Commanding is kind of one of those things that are required in any MVVM. Hold on. Let me take a breath. There we go. I learned how to drink water today. Okay. So what I want to do is now I want to talk about the delegate command. Delegate command. So let's come into our view. I'm going to change this to a stack panel. And let's add a button. And I'm just going to say click. And I want to invoke a command. So we're going to bind to a command. And I don't know what we're going to call this command. Any ideas? Binding, how about do something command? Work for you? Works for me. Okay, so do something command. So we want to invoke a command when we click this button. So in my view model, I'm going to use a code snippet, CMD. This is this is a code snippet in the Prism template pack. And I'm going to say do something command. Whoops, I hate it when Visual Studio does that. Right? Okay, so now we have a do something command. And all this is going to do, it's going to invoke the command from the button, right? The button's going to click this and invoke this method. Oh, Luis, can the parameter be a user-defined type such as an object? Yes, it can be. So in this case, I'm going to set the message equal to command invoked. Right, so let's do something real quick. This is really basic stuff, right? So what a delegate command allows you to do is respond to user interaction in your view model. So I'm going to click this, and we can see command invoked. So we click the button, the command was invoked, and then our execute do something command method was invoked in response to that, right? But this is where cool stuff happens. This is where Prism really takes off. So I'm gonna close this. I have too many windows open. Close that. Close that. Okay. Let's add a checkbox. Let's add a checkbox. We're gonna say this can click. Sure, can click. Sounds good. And then is checked. Let's create another binding to can execute. Or can click. Let's just call it can click. So let's go into our view model. We're going to add a property. In this case, I'm going to use prop p, which is a Prism property, Boolean. Let's say can click. Tell you, I don't know how to type. Can click. And let's set this equal to false by default. Okay, so what we want to do is whenever the can click button is enabled, we want to be able to click and invoke the command. So commands have what's called a can execute. I'm going to copy that name. I'm going to say can execute do something command. Okay. Maybe I should bring this down so everyone can see. I'm going to bring this to a new line here. Maybe that'll help. Like that. Bring this one down. There we go. I'm going to generate that method. And here I'm going to return and click. Right, so this basically says, am I allowed to invoke this command? Yes or no? So what I want to happen is whenever the can click property changes, right? I want to basically determine if I can click this command or not. So let's run this and just kind of see what happens. Let me drag this over. So right now, because can click is false, the button is disabled. I can't click it. So what I want to do is hit check it and say, yes, I can click it, but the button is still not enabled. Like, okay, what's going on here? Now, in a lot of command implementations, like there's a popular MVVM Lite relay command, this kind of happens automatically. And that's because it hooks into the command manager in WPF. However, Prism doesn't do that because that is a bad decision. The reason it's a bad decision is the command manager will requery the can execute multiple times, all the time. You have no control over it, right? This means if you have logic that maybe checks a database or checks permissions or has any type of code, substantial code to make a decision, you are creating one heck of a performance hit in your application. So instead, Prism makes you manually raise those events. So what I'm going to do, I'm going to show you one way to do that. One way is right here in the setter of the button. I'm going to say, hey, do something command, raise can execute change. I basically saying, hey, after this value is set, raise the can execute change of this command, which is going to reevaluate the can click to let me know if I can click it. So let's go ahead and run this application. I'm going to open up on this window. I'm going to click the button. Boom, it's enabled. I can now click it. Command invoked. Unclick it. Awesome. That's beautiful. Beautiful. But I don't like this. I personally don't like this because I don't really like having dirty setters. What I mean by dirty setters is having code in my setters and my objects. Instead, we're going to use a very unique feature of Prism. So if I come to my command that I've created, I'm going to just do a dot, right? So I'm going to say dot observes property and click. What I'm doing is I'm using a method off of the delegate command called observes property, and I'm providing the can click property. So what's going to happen is Prism's going to say, oh, you want me to observe this can click property? Okay, I'll tell you what. Anytime the can click value changes, I will automatically raise the can execute changed of the command for you automatically, right? You don't have to do anything. Just sit back. I got this. All right, so here's the same app. Can click, button's enabled. I can click it. I can unclick it. Same behavior. Except now we don't have to have code in our setters. We can just tell the command to listen for changes on that property. And you could do more than one property. Oh, I can observe another property. I can observe another property. I can observe another property, right? And so you can observe multiple properties at any time a value in those properties changes, the can execute will automatically be raised on this command. Now, you can also, like, for example, let's say I had a person object, right? You can dot into, you can have a complex property. So if you did have a person object defined in here, a person property, and it had a property you wanted, I can say, oh yeah, person dot property name, right? You could totally do that. Well, I know what you're thinking. You're like, Brian, that's freaking awesome. You blew my mind. Like, that's awesome. You know what? I think we can do better. I really think we can do better. So looking at this property, it's just a Boolean that says, can I click the button or not, right? It's a very simple check. Well, that got me thinking. It's like, well, you know what? The delegate for the can execute, look here, is a Boolean. So why should I have to define a method just to return a property? It makes no sense to me. So what if we did this? What if I deleted the can execute delegate, right? So let's delete this. Now what I'm going to do observes can execute and click. So now what we're doing is I removed the method for can execute from the command. Right now I'm going to say, you know what? Hey, delegate command, I want you to not only observe the can click property for property changes, I want you to also use the results of that property as the can execute delegate. What? What? Yes. Let's run the application and see how it functions. That's amazing, right? So here's the same app. I can click the button. I check the checkbox. Button's enabled. I can click the button. I can uncheck it. It works the exact same, except this time we've cleaned our code up, right? We've cleaned it up. I don't have to have extra methods for can executes because it's a simple Boolean. It doesn't make sense. Like, just let me provide the property itself, right? So that's a unique feature of the Prism delegate command that I really, really enjoy personally. Okay, I'm looking for questions. I am not seeing any questions right now. Okay.
I have a question.
Yeah.
Brian, can you use Prism for something like Xamarin? Just an idea.
Yes, you can most definitely use Prism for Xamarin Forms.
Wow.
Not native Xamarin, but Xamarin Forms. However, I will say, so Prism has 3 packages. Okay, it has the Prism.core. You'll have a platform-specific version like Prism.wpf or Xamarin Forms or Uno. And then you'll have a container package, like whatever container you're using. So when I say container, remember when I was explaining, hey, look, I just asked for this and they gave it to me. Well, the container did that for me. And so in this case, I'm using dry IOC, but some people like Unity. I used to use Unity a lot. So it's those 3 main packages, okay? But the Prism.core package, which contains the Event Aggregator, and it also contains the commanding and stuff like that, that is in a core .NET standard assembly, which could be used in anything. Anything .NET, you can use that in. I use the Event Aggregator in Blazor just as an experiment. Yeah. And so I have about 10 minutes left. So let's talk a little bit about messaging really quick. Let's say that when I click this button, I want to communicate with another part of the application. So in this case, I'm going to communicate with, I don't know, I don't have a lot of time. Let's just communicate with our shell. Okay, let's communicate with our shell. So let's open up our main window. Let's add something. I need to add a text block here. And we'll set the text equal to a binding of something. We'll call it message. Don't let me forget I called that message. That's all I need. Okay, so now let's talk about how do we communicate, loosely couple communicate from like view model to view model. Okay, to do this, we're going to use what's called the Event Aggregator. Okay, so I'm going to start just by creating a new class. Actually, let's not start by doing that. I'm getting ahead of myself. So what is the Event Aggregator? The Event Aggregator is a publish, subscribe communication eventing system. So it lets me communicate or send messages from one or more views or view models or objects or classes to other views, view models, and objects and classes, right? And to use this, the first step is we have to have an event. Okay, in this case, I'm just going to create it in here. I'm going to create a new class. I will call this class like, I don't know, what, message event? That sound good to you? Sounds good to me. Message event. And this is going to be a public class that implements or derives from pub sub event of T. Whoops. This one. Okay. And pub sub event is the event type of Prism. The T is the payload. So when I send a message or I send an event of any type, I can send a payload with it. And this string, in this case, represents the type of the payload I'll be sending. But if you had like a person object, you'd say like pub sub event person, because I'm going to send a person payload with this event. So now that I have the event defined, I need to send a message. So let's send a message. To do that, I'm going to ask for the Event Aggregator. Add our using statement. Right? Let's create a field. So when our message is when this is invoked, right? The execute do something command. When I click the button to invoke the command, I'm going to send a message, and this message is going to be Event Aggregator .get event, the type of the event, which I think I called it message event. Yep. Once I get the event, I'm going to publish it, and I'm going to send a payload with that. In this case, I'm going to send the message that we clicked on. Or you know what? Let's not do that. Let's do a custom message. Let's do I sent a message. All right, we'll do that. See a question. Can we use Prism and UWP2? Only if you're using Uno. Only if you're using Uno. Prism does not currently have a UWP specific package. Okay. But you can use the event aggregator and stuff like that in there. Anything from core you can use. All right, so that's all it is. So I got the event, right? I said event aggregator, get me this message event, and I'm going to publish this. Now that we publish this event, I need a subscriber to this event. So let's go to our main window view model. And what did I call this? I called it message. Okay, so let's create a new property here. A string message. Now, same thing. I need event aggregator. I need to add my using statement. And here we're going to subscribe to the event. So we'll say event aggregator get event message event. Now these events, if they're shared across multiple modules, you'll normally put it in like some type of infrastructure or core project. So like I'd have like my Prism demo.core assembly, and that's where all my shared stuff would go. But we'll say get event. We're going to subscribe, and what do we call this? Message received. Now we're going to generate that method. Well, now that we have our method, so whenever that message is received, we're going to set the message property equal to our payload. Let's run the application really quick, and let's see what happens. So here's our checkbox. I'm gonna click that. Uh-oh, my computer froze. Don't freeze on me. Don't freeze on me. Okay, let's try this again. It didn't want to click. I hope I didn't break something. Try it again. New AV model. Let me hit my breakpoint. I want to make sure we're at least creating everything. You can't have a demo without at least one issue. Oh, I know. Sorry. When I created this text block, I actually put it on top to set a margin of like, I don't know, 100. There we go. The text block is sitting on top of the checkbox, so I couldn't check it. There we go. Okay, so now I'm going to click this button. It's going to send to the event, and there's our text block that received the event, took our message, and displayed it, right? So I know that's a very simplified example, but that allows us to send messages all throughout our application using the event aggregator. And what's really cool about this is you can even filter events, right? You can create event filters. You can choose how you subscribe to the event. So where did I sub to that? Here? Was it here? Yeah, so we have actions for like, so by default, the event aggregator uses weak references, meaning that you don't have to worry about unsubscribing or anything like that. It handles it for you automatically. However, you can choose to have a strong reference by keep subscribers alive, right? But if you do that, you will have to manually unsubscribe. You also have a thread option. You know, do you want to publish this or subscribe to this on the background thread, the publisher thread, the UI thread? So there's a lot of cool little features within the event aggregator itself. Okay, so that's pretty simple. I mean, the event aggregator is pretty straightforward. And honestly, that's my time. I'm out of time. Man, I have so much more cool stuff to talk about. But that's all I have time for right now. So, if any questions want to come through, I can answer those. But other than that, yeah, that's it. Buzzer.
Thank you so much, Brian. Yeah, for the audience, please feel free to give your questions to Brian. No, Brian, I was thinking that by this time I would be, it's almost 9 p.m. here in Manila. I would be sleepy and everything, but man, your energy is just infectious. It must be the water. Must be that water in Boise.
It's the water. It's the water.
No coffee. No coffee.
No, I don't drink caffeine at all, actually.
Good for you. All right. So if there are any more questions from the audience, just would like to ask them. All right. Nothing's coming through at this point, but yeah, that was such an awesome presentation. I have not touched WPF for a long time, and
Yeah.
and this presentation has made me excited to try and get my hand on it again. I mean, even just that observes property thing that had been my pet peeve with WPF. Having those dirty setters and having to put those property change events on those setters is always annoying. So that was a great that's something great that I pick up from your talk.
Yeah, I appreciate that. Yeah, I've been using Prism so long, I don't know how to develop without it. Like if I just start writing a WPF app or a Xamarin Forms app, I was like, oh my God, how do I just navigate? Like, how do I just put a view in here real quick? Like, why is it so impossible? I was like, I forget.
All right.
Oh, Dave
cool.
Noder. Hey, Dave asked a question. He's like, hey, says, great job, Ryan. Appreciate it, my friend. Where else can we see you? Well, like I said, the easiest place is on Twitter. However, my YouTube channel, just youtube.com/Brian Lagunas, and then Twitch TV/Brian Lagunas. So I live stream today. I'll be live streaming, but you guys will be asleep by then. Yeah, I'll be live streaming at 10 a.m. my time, which is in like 4 more hours.
Yeah, so that's probably what 1 a.m. ours. All right,
Yeah.
which is why we're so thankful that you spent your time with us very early in the morning. Thank you so much. We appreciate that, and that was such a great presentation. So thank you very much, Brian. Virtual clap, everyone. Thank you so much. All right.
Yep. We got a question real quick. Hold on.
Yeah.
Okay, got a question. Luis is asking, hey, what's the roadmap for Maui? Any huge changes expected? So no huge changes, but we do expect Maui support whenever Maui is available. However, Maui has been pushed out to like 2022 or something like that. So yeah. And do you happen to know how Prism got its name? Yeah. So when Prism was first started with the Microsoft Patterns of Practice team way back in the day, they named it, and there's no special story behind it. It's just they were thinking about how all the pieces come together, because back then it was called the Composite Application Block. I don't know if you remember all the application blocks that the PNP team had back in the day, the logging application block, right? The application update application, like all these different application blocks. Yeah, and so this was just part of it, and they just thought about how everything kind of meshes together, and it's just a prism of all this functionality.
All right. I think that's our last question. So thank you so much for that.
Thanks for having me. I appreciate it.
All right, thank you. Okay, so I guess we're at the end. We're out of time. We're at the end of our event. So I'd just like to thank everyone who's been here. I think we're not limited to audiences from Manila or even just the Philippines. There's somebody who said they were from Tanzania, and I could see a few more nationality names, from other Asian countries. So thank you very much. Thank you very much for being here in this event. Please, I guess just as a reminder, please subscribe to our meetup.com page, meetup.com/, Finog. And yes, subscribe to our Twitter account. It's twitter.com/, Finog as well. And same, just search for Finog. And Facebook, feel free to join our Facebook group, and subscribe to our Facebook page. And yeah, we're working on our Finog website again with Blazor, and that's something that I will be that we will be ready to announce in a few months' time. All right, so again, this is John, and I'm the head of Finog. Thank you so much for being here. I know it's already late for the people in Manila, and appreciate that everyone who had stayed the full 2 hours. Great talks from Rocky Lotka, and great talk from Brian Lagunas, and all that energy. This is awesome, and we hope to be able to bring you more as to 2021 goes. Before I forget, I would also like to thank the .NET Foundation for hosting us. Dave Noder, Luis Beltran, who's co-hosting this event. Thank you so much for helping us conduct this event. And we will be back next month with more events from Finog. We hope to be able to continue this as we go along. So wait up. Yeah, subscribe to our meetup.com so that you know what's lined up next. Yep. So yeah, again, thank you. This is John, and magandang gabi, and maraming salamat po to everyone who has been here. So thank you and good night. See